Okay, this is question number 98. It says write an explicit equation for the sequence based on the graph at right. So let's get closer to this graph. And we're wanting an explicit equation for this graph. And we can read a couple points off of it, right? Whoa, can we? Let's see, 2, 4, 6, 8, 10. No, 4, 4, 8, 16, 17, 18, 19, 20. So it appears that each one of these lines is 4 units, right? That's 1, 4, 2, 3, 4, 5. 5 times 4 is 20. So each line is worth 4 units. So this first point appears to be at the point 1, comma, that's 3 times 4, 12, right? So the first value is 12. The next value appears to be at 20, 24, 28, 29, 30, 31, 32, 30, 36. So it looks like 2 comma 36 is a point on the graph. So 36 is the next value on the sequence. And the last value is pretty high. It's 100 plus 4 and 4, so this is 108. So the last one that we have that we can see here is the third term is going to 108. So comma 108. So I've got 12, 36, and then 108. Well, I can look at this sequence and I can see as I move from term to term to term, right, I'm multiplying by the number 3. And let's not just gloss that over, because sometimes when you guys look at these, you're like, I don't know what I'm multiplying, right? So how do you know? Well, one of the things you can do is if you take like a term on the sequence and you divide it by the previous term, right? So for example, if I take the 108 and divide it by 36, right? It's a term on the sequence divided by its previous term. Well, 108 divided by 36 is 3. And how do I know that? Well, I'm embarrassed to admit that I actually used a calculator, right? So 108 divided by 36 is indeed the number 3. 36 divided by 12, I can see that, right? I know 36 divided by 12 is 3 also. So this is multiplying by 3 each time, right? So my generator, I could say generator, each time I move forward I'm multiplying by 3. And the 0th term, that's interesting. So if this is the first term is 12, the second term, the third term, the term before that, right, if I'm multiplying by 3 to move forward, if I want to go back 3, if I want to go back to the 0th term, that would be 12 divided by 3, which is nice. It's just the number 4. So I've got the 0 term, the 0th, that's funny, I don't even think that's a word, term is 4. And then I'm ready for the sequence, right? So if I've got this is a geometric sequence, right? If I have a geometric sequence, it always fits this pattern, right? T of n is the 0 term, right? And I'll just call it a, times your multiplier raised to the nth power. So I'll call this b. So just so you can see the pattern here, my multiplier is b, multiplier, and you know, your multiplier can be a fraction less than 1, in which case your sequence would be decreasing, so you could be multiplying by a third or a half or a fifth. It doesn't have to be a number greater than 1. And the 0th term right there is the term before the first term, so I'll just write 0 term. So I've got all the components that I need, right? I know that my 0 term is 4, and I know that my multiplier is 3. So this sequence is T of n equals 4 times 3 raised to the nth power. And you know, it's kind of instructive to just grab some numbers and plug in. Notice when I plug in the number 1, right? 3 to the, if n is 1, 3 to the first power is 3. 3 times 4 is 12, which is exactly what it should have been, right? When I plug in the number 2, 3 to the second power is, what is 3 to the second? 3 to the second is 9, yeah, and 9 times 4 is 36. So when I plug in a 2, it gives me exactly the number 36. And then finally, when I plug in the number 3, 3 to the third power is 27, and 27 times 3, I'm going to assume is the number 108, but I should probably check that real quickly with the calculator. Yeah, 4 times 27 is 108. So I can see that this is doing exactly what I want it to do. This is the explicit equation, right? 4 times 3 raised to the nth power. So geometric sequence, you've got your 0th term times your multiplier raised to your power, right? How many times you're multiplying by that base.